Hey folks, Mr. Kowalczyk here. I'm just calling to let you know that I'm not there today. So what we got is today we have lesson 5, proofs with segments, so line segments. First thing you're going to do, please pause the video and then go add these two knowledge cards to your rings. Okay? Please pause it right now and add these in there. We got the segment addition postulate and the midpoint definition. All right, hope your note cards are done. Moving on, we're going to do proofs with segments. Okay, so our learning target for today is I will understand how to do proofs with line segments. I know that's a huge shock. Okay, please jot that learning target down. All right. Now, first off, we're going to jump in with our first proof right up here. And in this case, we have A being the midpoint of segment PK. And we know that GB is equal to PA. And we're trying to prove that GB is equal to AK. So first thing that I like to do with these proofs again is I just like to look at the diagram and mark them up with what I know is true. If A is the midpoint of segment PK, then we have a midpoint here, and it splits PK into two equal parts based on the definition that we just put in our knowledge card. Now, we can say then that this segment is congruent to that segment because they're equal to each other. Okay, cool. So that's something that we know. Now, we also know that GB is equal to PA. So with PA being here, and we put one tick mark on that, that means that this is the same length as this. But it also means that PA is the same length as GB. So we can also mark this up with one tick mark saying that 1, 2, 3 things are all the same as each other. All right, cool. So we kind of got the idea about how to prove this. So now what we're going to do is write it out. So as always, our first step is the given. A is the midpoint of segment PK. Okay, and we can use our notations. And what's our reason for that? Well, of course, it's always given. Yeah. And then after that, what we know we have is step 2. So we said that, oh wait, I forgot my other given. I want to use them all at once here. So GB equals PA. For step 2, what we're going to do is we're also going to say that PA is equal to AK. And why can we do that? Because of one of the knowledge cards that we took today. Maybe you already noticed it. It's the definition of a midpoint. If we have a midpoint, it splits the segment into two equal parts. All right. Now, if I see that PA is equal to AK and PA is equal to GB, I can now set those two equal to each other, where GB is equal to AK. Now in this one here, we can use either the substitution or the transitive property because we're setting the whole side of one equal side equal to the other thing. So I'm just going to go ahead and use the substitution property of equality. Okay. We've said that GB is equal to AK. That's what we're trying to prove. And we're done. Great. All right. Now, this one's a bit more complicated. What we're told is that PQ is equal to RS. So then we can mark those as congruent here. And what we're trying to prove is that PR is equal to QS. So in this case here, I'm going to use some numbers to show you kind of what I'm doing. Now, it's not related to this. So I want you to see if you can kind of forget about the geometry part first. And then what I'm going to do is I'm going to say, if we have numbers, right, and we know that we can just say 4 equals 4. Well, if we add 6 to both sides of this, plus 6 and plus 6, that tells me that 10 is also equal to 10. And the same idea is true here as well. We're told that PQ is the same length as RS. So what I'm going to do is I'm going to add QR to PQ, and I'm going to add QR to RS, just like I added 6 here to the same thing up there. I did it with numbers here. I'm going to do it with line segment here. If I have something that's equal and I add the same value to the two things that are equal, I'm going to get the same value also. So let's go ahead and jot that out in our proof here. So we got number 1, PQ equals RS, and that's our given. And now the next thing I'm going to say is that PQ, no, sorry, I need to use my reflexive property because I'm adding the same thing to each sides. So I'm going to say QR equals QR. So then what that means in this case is the reflexive. So now I can add QR to both of those things. PQ plus QR equals PR, right? PQ plus QR is PR. And I can also say that RS plus QR equals QS. And what is that? That's the segment addition postulate, because we added 2 pieces of segments together. Okay, so now we got that. Let's focus up. All right, so now what I need to do is I need to set this side equal to this side. So for step 4, oh, that's a wacky 3 there. All right, for step 4, I got PQ plus QR is going to equal, nope, I apologize. I need to change this step here so that it's the same as this step here, because PQ and RS are equal to each other from my givens. So I'm just going to substitute in PQ for RS here. So I have PQ plus QR equals QS. So really I just took this line here and just substituted in PQ for RS and rewrote it here. Now I have PQ plus QR is equal to QS, but I also have PQ plus QR is equal to PR up here. And that, number 4, is my substitution property of equality. Now for step 5, this equals QS, and this, the same thing, also equals PR. So I can say PR equals QS, and that's my transitive property of equality. PR equals QS, PR equals QS. We're done. Okay. All right, next one. And if I'm going a little fast while I'm talking, please feel free to just pause the video and copy stuff down or rewind it. Thanks. All right, PR equals QS. PR equals QS. And now what we're trying to do is PQ is equal to RS. So now in this case, we're actually going backwards. So what I'm going to do is I'm going to mark this segment here as PR, and that's congruent to QS. So PR equals QS. That's my given. Now, instead of adding QR to both, what I'm going to do is I'm going to subtract it from both. So for step 2, I know that PR is equal to these two added up together, PQ plus QR. And I know that QR, or sorry, PQ is, no, I was right, QS. QS is equal to QR plus RS. This part plus this part. And again, that's my segment addition postulate. Step 3, we know that PR is equal to QS from our given. So I can then set this and this equal to each other by the transitive property. So I have PQ plus QR equals QR plus RS. Now I have QR in both pieces. I can subtract QR from both sides. Step 4, PQ equals RS because this and that cancel out. And that's my subtraction property of equality. Awesome. Okay, last one for the lesson. Now we have these two triangles. Let's zoom in on these a little bit and focus in because the letters can be a little bit hard to see. Let's get a little closer because they're still kind of hard to see. All right. So we know in this particular setup that we have triangle ACM and triangle DBK. Let me rewrite these letters because they're super small. ACDB, and then we have M and K. I don't know why they're so small. All right, we're given that AD here is equal to CB here. So kind of similar to what we were just doing before. And now we're trying to prove that AC is equal to DB. And we've got our steps written out for us, which is great. Well, AD equals CB, that's going to be our given. Yeah. Now we have to look at the steps to try to figure out what's happening here. We have AC plus CD. AC plus CD, that's our segment addition postulate. We're adding two pieces of a segment together. And then we have CD plus DB equaling CB for step 3. That's also the segment addition postulate because we're adding two pieces of a segment together. Okay. All right, cool. We're halfway done. So now we say AC plus CD equals CB. Well, what I'm noticing is that we have AC plus CD equaling CB. So a whole bunch of stuff changed. Well, we know that AC or AD is equal to CB. So that's our given. And what we also know is that we can take this one here and swap out CB in place of AD because this and this are equal to each other. So this just turned into CB right down there, and this stayed the same as it did up here. So when this changes to that, that's going to be our substitution property of equality. Now, if we have this thing equaling CB and this box here equaling CB, then we can set them both equal to each other. AC plus CD is right here, and CD plus DB is right there also. So that's going to be our transitive property of equality. And then because we have CD here and there, we can subtract it away from both sides, and we're just left with AC equals DB. Oops, not transitive. Oh boy. Fraction. Really. Said it out loud and then wrote it wrong twice. All right. So that's the end of the lesson for today. Now, after that, there are several different partner proofs. So what I'm going to ask you to do is with a partner, please go ahead and do 3 of the partner proofs. You're going to do them with a partner. If you want to take turns, if you want to work together, that's a-okay. The answers to the partner proofs are in Schoology. So if you could please check your work and remember what I've been talking about already. Use those answer keys as hints. You don't want to use them as a cheat, and you don't want to overuse them because it's not going to help you grow and learn how to do these proofs. So just like look, if you're stuck on step 3, for example, just look at the answer key for step 3 and then put it away and try to solve the rest of it by yourself. Okay. All right. Thanks a lot, and I hope this was helpful. Have a good one. Bye-bye.